like in the list, like I just randomly choose the EE apps 4, okay, or you don't need to identify which server you want to connect. You can just use the EE apps. So once you open a new session, you need to log in with your account. So here I use my TA account. And you connect with that. If you haven't used mobile Xterm before, so basically here is your command lines. You can type the command. On the left is your home directory. And if you follow the tutorial, I ask you to go down to the tool setup file here. First, you need to make your own directory so that you won't mess up with other courses. Here we make the E15C and go into the E15C and copy the setup files, like the libraries and like which software we are going to use. That is the tool setup file. So I have copied that. So here I can show you briefly. Here is the tool setup file. So what does it have is it defines where the cadence is. Here it tells you, okay, here we use the cadences under this directory, and this IC 617. And we have the cds.lib that defines all the libraries that we are going to use. If you create a new library, it will also appear in this file. So you can open this to have a look at. So basically what we include is this two libraries, PDK 90 nanometer. So it include all the components under the 90 nanometer technology. Some basic cells include like we use this analog lib, which has the power supply, the ground, all those kind of fundamental components. So then we can get started and use the CD and go to the directories that we have. Okay, and then you source the tool setup file. And then you use the virtuoso to open the cadence. What happened? Let me pause the recording. There's some issue.
Okay, so should be had.
I have what?
Yeah, it says that there's two instances holding a lock on the lock state file. So you need to close one of them over next time. Just not one of them.
Oh, okay.
Physics to that, right?
All right. Okay, we have the cadence open. So here you have the log window. Like if you have any errors, it will show here. You can check like if the schematic error or simulation error or whatever, it will pop up here. So first you go to the tool and you have the library manager. You open that because everything is done under certain library and certain cells and views. So if you look at the library, like here is our 90 nanometer technology library. You have all the NMOS, PMOS, and all the like even the BGT capacitors, those kind of things under the library. You can click the show categories to show the type of the devices. Here we're using MOS, so here we have NMOS, PMOS, and here under each cell, it has the views. Like views is like you have the symbols or the layout or some other parameters are included here, right? So now we are going to make our own a library because we want to test our own circuit and like build our own schematic. So we first build a new library. So file, new library. I'll call it 115C demo. And click OK. And here you need to attach it to a existing technology library because for the library you want to use the symbols from the 90 nanometer technology. So you need to attach to an existing technology library. So choose that. And here you choose the technology library, which is 90 nanometer. And then you have the 115C demo. So it's empty. We want to create a new cell. So first go to the file again, new cell view. The cell view, like now we want to create a schematic. So here the view is schematic and the cell name. Here, for example, we want to build a useful schematic. Useful means it's your homework 1. So if you go to the homework 1, if you look at problem number 1, here you want to simulate a transistor model, use vector and extract the informations. So here you need to generate a family of IV curves for NMOS transistor. Here's the dimension and sweep the VDS from 0 to 1 in this increment, and for different bias voltage, like different VGS and different VSB, right? So the idea is at the end you want to get, it's not updated, but whatever. This is okay. So we want this curve, right? Like this is, so we sweep the VDS for different VGS. Like we want to generate this curve. So now let's build the circuit. Go back to the cadence. Here we create a new, so we call it IV curve. Here you can either open with schematic L and XL. There's no big difference between the two. So click OK. Okay, and the schematic pops up. So here you have a couple of things. Here is kind of you rotate the components, zoom in, zoom out, wires instance. So first you want to insert NMOS, right? So here is a create instance. If you can look at here, and the shortcut key is I because for instance. And here you can browse. You go to our technology library, and you use NMOS 1 volt. And once you choose that, make sure you choose the symbol because you want to insert the symbol of the NMOS inside your schematic, and you can click close. And here is a property window of the NMOS. See here you have the length, width, and certain other diffusion rates, fingers, those kind of things. And then you can go back to the schematic and click it, and then it's inserted. You only need one NMOS, and the other thing you need is a voltage source, a ground to make it to be a complete circuit. So the ground and voltage sources is under analog library, and here you can search it. Like here is a search. Because we use the DC voltage, it's not a waveform, it's just a constant. So here we search VDC, and the voltage source is here. So you can click the close, go back, and put it somewhere. That's the voltage source, and we also need to insert the ground. That's a reference voltage, a reference ground. here in the library it's called GND. So close it. And put it here. You can press the key F to zoom in to fit zoom, and then you connect them. So normally what I'd like to do is not connect all of them with wires. You connect them with the net names. So for the ground, they are close. Another thing is I don't like to connect the ground directly to the components because here is GND by default. This net is called GND. Like you cannot change the property of this. Like normally we would like to connect the GND to a voltage source, and from the voltage source we make another net that will be our reference net. Why is it like that? Because in practical circuits sometimes you have the noise, like the noise or whatever, you need to model them so that you can model them as a voltage source or whatever, and you can also see the total current through a certain device. So just put a 0-volt voltage source here to change the net name and also be able to observe the total current goes into the ground. So that's a kind of trick people normally do. So name this net, the ground net, that will be VSS. Right here is VSS. Basically, it has the same potential as the ground. So here the transistor, the bulk, the body is a ground. So make it to be VSS. The source, we don't want to connect to the ground because if you look at the problem 1, you need to assign different VSB, right? VSB have 0 and 4, like which means the source voltage is not equal to the body. Like you need to apply certain voltage across the source and body. So next we need to insert a couple other voltage sources because we want to apply the bias voltage for the gate, drain, and source. Right, copy this, press the key C to copy. Copy it a couple of times. Okay. First we create the VSB, which is a source voltage. So VSS is the body. So the net above it will be the V source body, right? So here we name it to be VSB. So here's a label. I didn't mention that. Here the wire name is also the label. Here we call it VSB. And here we define the source voltage. We connect to the source. And then we want the gate voltage. And the gate voltage is actually VGS, right? So VGS is the voltage referred to the source. So here, if we want to make this voltage source to provide the VGS, the negative terminal should be VSB, and the positive will be VGS. Because VSB is the voltage at its potential at the source terminal. So here will be our VGS. And the last one is VDS. Actually, VDS is also referred to the VSB. VSB will be the negative node, so you can connect them together. You can change just copy the wire so it's easier, and you can just the name here to be VDS. Right now we have the circuit, and then we need to connect the voltage source to the transistors. Make sure you save pretty often so that, like, if there's an internet issue, like you can still keep them. So you see here is highlighted because this net is not connected to any other thing, so that is highlighted. There's a kind of warning. So we want to connect the VGS to the gate and the VDS to the drain. Right. So this is our complete circuit. Can save it. So that's what I suggest. You use the net names to connect them instead of use wires, because sometimes you need to route it to make the circuit hard to follow. If you can use a trick here, you can click the view, and there's a net highlighting. So you to highlight the net with the same name. Basically, if you move it to the VSB, you see it's highlighted, they're connected. And VGS is connected to the gate, VDS connected to the gate. Okay, so now the schematic is done, and then we need to set up the simulation. So how to set up simulation? Like in the tutorial that posted on the Brain Learn, they use ADEL. So ADEL is it's a pretty old tool used for simulation, and there's another one. It's called ADE Explorer. It's introduced like in the last 5 to 6 years, or maybe 10 years. That's a newer one. It has it covers all the functions that ADEL has, but it's more powerful in the parameter management and all the other things. Like I think in most of the companies they use ADE Explorer instead of ADEL. If you want to try ADEL, you can just follow the tutorials. But today I'm going to show how to use the ADE Explorer. It's a pretty similar, but and a little bit different. So if you click the launch ADE Explorer and you create a new view, that's kind of create a simulation view or simulation setup file. So here, the view is another name, it's called Maestro, but the cell is still for our IV curve cell. So kind of open. And you have this kind of window. So if you go back to our the library manager, you see here under this 115C demo library, we have this IV curve cell, and we have a new view, which is our simulation setup view, like the master and also the schematic. So if you go back to the here, so a few things you need to do. First is look at the model libraries, say if it's attached to the 19 nanometer technology file, because when it's a run simulation, it needs the model parameters of the transistors under from this file. So you have to make sure it's connected to the correct model files. And also here, the session, it defines the corners. Here, I think it's by default, you use the NN corner, typical corner. Next, you set up the analysis, which is what kind of a simulation you want to run. Here you have the transient simulation, is versus time, how the signal changes. And also you have the DC analysis, that's what you want to use. And AC analysis is kind of, you have an AC source, you sweep the frequency. You know, you have learned the body plot and the magnetic, those kind of plot. That's a frequency response, you need to run the AC. And some noise analysis, like by far you don't have to use that, but later, like if you still work on the circuit, you may use that. So now we use the DC analysis because we sweep the DC signal and look at the output. And next is what parameter we want to sweep. Right? So there are a couple ways to work with this problem because here we haven't defined any design variables. So basically you cannot use this option, but I can show you how to define a design variable in very short. So here, if you go back to our schematic, we have 3 voltage sources. We want to change the value of them, right? So for example, here we have the VGS. Here the DC voltage by default is 0, but we can assign a variable to it. We can call it VGS, little VGS. Right? So then this little VGS is our variable that we can change the value. Similarly, the VDS, we can assign a variable. And here, this VSB, like the DC voltage, we can also assign a variable like VSB. And then we define the 3 variables, super easy, just type a certain variable you want to use. And then if you go back, here you have the design variables. If you click this, and here you have the cell view variables, and you click the copy from, it's kind of update the variables from the schematic to the ADE Explorer, and click OK. See here you have the 3 variables. You have to, when you have a variable, you have to give it a certain default number. Like even if you want to swap it, you have to give a default number. Otherwise, the circuit don't know like what's kind of a default condition of the value. So here, VDS, we can just give the 1, DGS 1 again, VSB give it 0, right? Let's go back to our analysis again. So analysis here, we do the DC analysis. Now we can choose the design variable, like select the variable. We want to swap VDS, right? So VDS, and then where do you want to start? Start from 0 and stop at 1, and at which swap type we use linear. And step size is 100 millivolt. So here's a 0.1. And then that's it. Like you can click OK and then it's done. So here's the swap variable. There's another way to do it. Here we define the design variable, or you can use the component parameter. Like because for voltage source, there's a component parameter that is the VDC, right? So if you click this, choose the component that we want to swap, that is this voltage source, because we want to swap the VDS, right? So which means we want to swap the VDC of this VDS voltage source. All right, you can click OK. And if you go back to the setting, you see here, like it swaps the component like V3, which is our VDS voltage source, and swap the DC voltage. So both work and they are the same. Like you can choose either way to do it. Here we just choose the design variable and you can apply or OK. Okay, then you can go back to the window, the setup window. Now it seems everything is set up, and then next we want to add output, like what we want to plot, right? So go to click the output here to be plotted and select on design. And then it will jump back to our schematic because it asks you to select the net or parts you want to observe. Here we want to see maybe we want to see the current. So just so wrong. I should click this one. If you click the part, it will be a circle, and that stands for you want to observe the current. And to click the net or the wire, it's kind of you want to observe the voltage. I want to see the VDS, the VGS, and also the part, the current. And then we're done with the selection, and you can press ESC to cancel that. Otherwise, you are still in the selection mode. And then go back here. You see here we have a couple signals pops up like that we want to observe. Here, one more thing that is we want to, right now we're sweeping the VDS, right? But in the problem 1, we want to assign different VGS, right? It's a different voltages. So it's kind of, we run the DC analysis, but we sweep the variable at the same time. So how can we sweep that? So for the VGS here is a 1, but if you click it, see here you have a button. And if you click the button, it's kind of tell you like either from certain value to some value, or you can just make a list that all the variables you want to sweep. Here we want to run 0.4, 0.5, 0.6 as an example. Like in the homework, you have more. Or you have 0.8 and 1. You can run it by yourself. Here, it's kind of you set it up, and then you can run the simulation. Just click the run button on the right. It should be pretty fast, but okay, some error pops up. So if you have errors, don't be nervous. Just look at what happens. Okay, it turns out the signed disk for TA is full, so we cannot like write the files so that we encounter that error. So now I just deleted some files so that I hope we can run the simulation again this time. Okay, so the curves pops up. So here we have different VGS, and we have the IV curve, the VDS versus the current. We have the 3 curves set up here. You can use the cursors. For example, the vertical cursor, press the key V so that you can move it and see what's the current for a certain VDS. And you can remove this, and you can press H to see a horizontal curve, see under a certain current, like what your VDS should be. Or you can press the key A to pick up a certain point, and press the key B, and so that you can measure the delta X and delta Y of 2 points. Right. Okay, so this is the VGS versus for different VGS, we have the VDS. Sweep the VDS. We can do another thing that we showed in the discussion. That is when we sweep the VGS and see what will happen. So now we change the variable to be VGS and linear 0.1. And here we only have one VGS, so just to give a certain number. Okay, so then we can start the running. And we have this curve. So this is what we just discussed. Like initially it's in cutoff region, and then after the threshold voltage, it turns on and works in saturation region, and then it goes up quadratically, and later it goes up linearly in velocity saturation region. That's what it is. So we can also do one more thing, that is to measure the resistance across the transistor, because in problem number 2, homework 1, you have that kind of question. So what you can do, you can add expression. So here you can add expression, and you can add it here by click this button. So the voltage as the resistance is voltage over current. So we use the DC voltage. So by VDC and enter. So you can choose like what kind of the DC voltage you want to use. We want to use VDS over the IDC DC current. That is transistor current, and then you can actually evaluate the value here by press this button. So you have for different VGS, you have the kind of the this resistance, or you can plot it by click the plot. Go back to your curve. Here, this is the resistance for different VGS, right? And the axis is shows on the right. And you can click OK so that you make this expression. Okay, that's pretty much for the simulation introduction.